Hey Kirsten, okay, let's see if we can make a little bit more sense of these problems. I know these are some pretty tricky problems. I've noticed when I teach this in the RN math that these are kind of the most confusing questions typically. So let's walk through these one at a time. So I'm looking at the first one. The first one says that we have a patient who is 252 pounds. We have an ordered dosage of 5 micrograms per kilogram per minute, and the medication is packaged as 400 milligrams per 250 milliliters. So here's what has to happen on these. So here's all the information that we're going to use. We are going to use every bit of this. If you think back to when we did dosage calculations, with dosage calculations when we did the D divided by H times Q, we were just given an ordered dose to get, the D. That was just what was ordered. H and Q are what we have on hand. That, in this case, is what I'm going to circle here in yellow. So that's going to be our H and our Q in the problem. However, we need to figure out specifically what my patient needs based on this information in green. That it says here that they need 5 micrograms for every kilogram. So we know what they weigh, so let's think about what that means for our patient. So for our patient, if we took 252 divided by 2.2, that would give me 114.54545454, repeating. So that means that our patient needs 5 micrograms for every one of those kilograms. So what I do is I try to kind of eliminate this kilogram part first and just kind of dwindle this down. That what we're trying to think of here, and this is how I showed, I think in those videos that I sent you before, that we have micrograms, or I'm sorry, we've been ordered, micrograms per kilogram per minute, and we need to get it to milliliters per hour. So what's happening is we need to incorporate their weight. We need to also get it from minutes to hours, and then we also need to figure out how we get from micrograms into milliliters. In any of these cases, it's just taking it one step at a time and trying to think about what we have in front of us and then how we can get it to this point. So with each of these steps, and I think I may have showed this in the video, with the kilogram, we're just going to simply multiply by that kilogram weight. To get it from minutes into hours, we'll end up multiplying by 60. And to get it from a unit in grams, like whether it's micrograms or milligrams or even grams, to get it from some type of form of gram that's a solid and convert it to milliliters, we're going to need a dosage calculation. So that's what we have circled there in yellow. So in order to get from, the yellow arrow that I've drawn there, in order to get from that solid dosage to get it into liquid, we need a dosage calculation. So let me get some of this out of the way and let me explain what I mean, because when we went back, just thinking real quickly, we'll go back to that problem, but thinking quickly back to dosage calculations, what I mean by converting any type of gram, whether it's milligram, microgram, what have you, in order to get that into then milliliters, which is what, we want here. Back when we did dosage calculations with the D divided by H times Q, that was, if I said that we've ordered, say, 50 milligrams, and we have a medication that's packaged as 10 milligrams per 1 milliliter, well, that means we would need to give them 5 milliliters. That's what this means right here, that for every, 1 milliliter of that liquid, it's going to deliver this amount of medication. My patient needs this amount of medication. So that's what we did, is we stuck that in a dosage calculation that said, here's ordered, here's what's on hand per our quantity, 1 milliliter. And our answer then was, when we took 50 divided by 10, those units canceled out and left me with milliliters, which is what I want. So that's why we ended up getting our answer to milliliters. So that's what I mean when I say convert from, so back up to the top there. So back up here, to convert from any type of gram unit to get it into milliliters, we have to have a dosage calculation like we have here in order to get that to happen, to go from our order dose of milligrams and get it into milliliters. That's going to have to be put into a dosage calculation. So going back to what I was showing you on, that example that you have there, when I've been ordered, 5 micrograms per kilogram per minute, those are the 3 steps we're going to have to incorporate here to get it into milliliters per hour. So I'm going to have to, like I said, incorporate the patient's weight by multiplying by that weight. I'm going to have to convert from minutes into hours because there's 60 minutes in every hour. And then I'm going to have to do a dosage calculation like what we just did to get it from micrograms to milliliters. The great thing about these problems, it does not matter the order that you choose to go in. You can do, in looking at just circling these steps, you can do this one first, or this one first, and it does not matter. It will not change the answer at all. You can do it in any order you choose, and you'll see that you'll end up getting the same answer every single time. But let me show you how I typically think about it. So what we just mentioned is when we converted that patient's weight from 252 pounds, what it was originally, and we were trying to convert it into kilograms, we took that and divided by 2.2, and you probably already know this because you divided that by 2.2, and that gave you 114.5454454 repeating. Typically in peds, they tell you to just leave that in your calculator. As far as, yes, you could round that off to 114.5, but typically in pediatrics, they tell you to just leave that answer in your calculator and then just keep going. Because then you'll be able to, you're using a very specific weight for your patient, so there's really no error involved there. So that's what I'm going to do. I'm going to leave that in my calculator. That's what this patient weighs in kilograms. So if we want to think about what's being asked of us up there at the top, just circling this in yellow, we were ordered to give this patient 5 micrograms for every kilogram every minute. So for my patient who weighs 114.5454 kilograms, we take that number, multiply it by that order dose of 5, and again, right now it's still in micrograms, and that's okay for now, but I want to know what that means. How many micrograms does my patient need? So I take that number and multiply it by 5, and it gives me, and again, I'm still just going to leave this in my calculator, but it gives me this number, 572.727277, just repeating. So that means that my patient needs that number in red down there. They need that many micrograms every minute. So see what we've done based on, from the ordered dose. So our original ordered dose, so circling that in red, was this. And we've eliminated this part of it. We have multiplied by the weight, so now we know the specific number of micrograms my patient needs every minute. Okay, so let's clear this out of the way here and just kind of write down what we have right now. So again, that means my patient needs this number of micrograms every minute. And like I said, so that allowed us to, in the original ordered dose, which I'll write down here, which was 5 micrograms per kilogram per minute, that has allowed us to eliminate the per kilogram part, and now we know exactly what my patient needs in terms of just micrograms every minute. So the next step is going to be, I'm going to go ahead and say, okay, well, if they need that amount every single minute, well, what would that be in an hour? If they're getting this every single minute, we're getting that, 60 different times in an hour. So therefore, they're getting that amount of micrograms 60 times. So I'm going to go ahead and multiply that number by 60. So leaving that answer in my calculator, I'm now just going to hit times 60. And that tells me that my patient needs, and it's a super big number, but it's 34,363.63636. And that again is now how many micrograms they need every hour based on their weight, which is what we did first. Since they're getting that number 60 different times in an hour, that's why we multiplied it by 60, which then in turn gave us this. So we've now, going down to the very bottom down here, I've now eliminated this part, and I've now got it into now micrograms per minute. I'm sorry, micrograms per hour. So we've got it down to at least that. We've got that part. Now, again, remember the end goal was not micrograms per hour. I want to know what it is in milliliters per hour. So we're done with that part. We don't need to do anything more with the time. Now, again, as I showed you before, to get it from any type of gram unit into milliliters, we simply just plug that into a dosage calculation. So let me get this out of the way and show you. We'll plug that into a dosage calculation. So here's what this says now. We need 34,363.363,636, and again, that's micrograms. If I were to plug that into a dosage calculation, the problem is what we were told in that, as far as the drug, how it's supplied, it says that a 250 milliliter bag of normal saline contains 400 milligrams. So our H and our Q, when we go to plug this into D over H times Q, our H is 400 milligrams and our Q is per every 250 milliliters. So if you remember what we talked about when we are performing dosage calculations, that we want D and H, so we want these two numbers to be matching units. Right now, my order dose is in micrograms. So before I plug that into this dosage calculation right here, I am actually going to go ahead and first convert that into milligrams. So thinking back to our metrics, micrograms to milligrams or micro to milli is what we're thinking of here. So when we use that metric chart, remember we called it the kiss hairy dogs but drink chocolate milk mom chart. That showed us that, again, micro's down here and here's milli, that was just 3 movements to the left. Or, again, some people, I don't know which one you use, some people use the stair-step method for metrics, which just required us to remember kilo, base, milli, and micro. And I'll put a C there for micro, and that was just up 1 step on the stairs, which meant we divide by 1,000. So if we did that, leaving that big number in my calculator and dividing that by 1,000, or again, that's the same thing as just moving 3 places to the left, that means that my patient needs just 34, and I'll plug that into the dosage calculation there, 34.363636, and not that you have to write all this down, but I'm just leaving these in my calculator as I continue to move forward. So I'm just going to leave that exact same number in my calculator, but now that it's in milligrams, it's going to cancel those two out and leave me with the milliliters that I want. So doing that, I'm going to take that number, divide by 400, take that and then multiply by 250, and we get this number, 21.4777273. I mean, just, crazy numbers here at the end, but that means now we can round. Typically, ATI exams will have you round to the tenths place when you're dealing with milliliters. So that means, rounding to this place right here, that means my patient needs 21.5 milliliters every hour. So I know in explaining that, I did a lot with that, but a way to think about that is just you need to really take that one step at a time. For something that's ordered that way, and then we need to get it into milliliters per hour, let's take it by each step. So that's what we got there for number 1. So I'll go a little bit, won't go as elaborate in number 2 here. In number 2, it says a dose of, now this time, 6 micrograms per kilogram per minute has been ordered. And we need to give that to a patient who is 75 kilograms. So I'll write that down here too. 75 kilograms. We don't have to convert that weight. That's cool. And the supplied solution is 500 milligrams per 250 milliliters. So very same thing. The idea is I want to get it into milliliters per hour. So we're trying to go from here to milliliters per hour. So once again, with each step, if our patient needs 6 micrograms for every kilogram, well, our patient weighs 75 kilograms, so that means they need 75 times this amount of dosage there. So my first step is going to be to multiply by 75 to eliminate this portion of it. And so in doing that, 6 times 75 gives me 450. So that means my patient needs 450 micrograms per minute. And again, since they're getting that every single minute, that means they're going to get that 60 different times in an hour. So that's going to be the next step to eliminate the per minute and get it into hours. So that's what I do. I multiply that by 60. 450 times 60 is, big number here, 27,000. So that means my patient needs 27,000 micrograms every hour. We've eliminated that per minute. We've got it to hour. So that's the amount of dosage that they need every hour, but we want to know what it is in milliliters per hour, and that's going to be based on how it comes. Because it does come in milligrams, not micrograms, I am going to convert my micrograms into milligrams here. So converting this number right here to make sure it matches, the dose that we have on hand, that again is either moving 3 places to the left or divide by 1,000. So that means my patient needs 27 milligrams per hour for a medication that comes as 500 milligrams per 250 milliliters. And so that, again, when we divide that out, 27 divided by 500, again, we do that because those will cancel out and leave me with this. So 27 divided by 500 is 0.054 times 250, means that my patient needs 13.5, I'll write that over here, 13.5 milliliters per hour. And there's our answer. Okay. And I'll go ahead and walk through that last one too, just because we want to make sure that we see all of them, and hopefully this is making a little bit more sense now. Let's see, patient is 160 pounds, so we'll have to convert that weight by dividing by 2.2, and we'll do that. Let's see, 160 pounds to receive a titrated infusion of medication between 5 to 10 micrograms per kilogram per minute. Oh, this is a fun one. This is a range. Okay, I'm going to go ahead and convert that weight. 160 divided by 2.2 is 72. Let's write this out this way. 72.727272, and so on. Okay. So this time, this one's a little trickier because it wants to know the range in micrograms per minute. So again, in incorporating the weight, since this is what our patient weighs right here, their range is 5 to 10 micrograms per kilogram per minute. Number one is asking for the range in just micrograms per minute, so meaning that we just need to eliminate this part. So what we do is we multiply each side of that range, the 5 and the 10, by our weight. So in green there, that number. So I'm going to take that 72.727272, that whole thing, I've just left it in my calculator, multiply it by 5, and that means that on the low end, and I would imagine it's okay to round at this point because we're putting in our answer. That means that on the low end, my patient needs 363.6 micrograms every minute based on their weight. Multiplying that by the high end, 72.727272 is going to be 727.3. I'll just round that off because it was 727.2727. So 0.3 micrograms every minute. All we did was we did the first step that we've been doing in the last two problems by multiplying the weight, but since it's a range, you simply just multiply the weight by both numbers, and that's what number one is asking. It's just asking for the dosage range, so what's acceptable as far as milligrams per minute. Let's see, then number two says, what is the manual infusion range in drops per minute for a micro drip IV set? Okay. Okay. This is interesting. Okay. So what that means, so we've done the first step, that this is what the patient needs on both ranges. What we'll end up doing on this one is we end up kind of doing what we've been doing, but twice, because we're doing it on the low end to see the low end of the range and then on the high end. So what we're going to see here is this is what our patient needs in terms of micrograms per minute. and I need to know what my patient needs in milliliters per hour. So, and I'll show you why we take it to milliliters per hour in order to get the answer to number 2. So here's our, let me see if I can erase a few of this up here. So here's what we have as far as the low and high end of our range for what our patient needs. Again, we've just multiplied by the weight. Now we're going to do the same thing. You know, again, we have it down to micrograms per minute. And again, the end goal is to get it to milliliters per hour. So kind of 2 steps involved here. We are still going to have to multiply it by 60. And we are going to have to still get it into, really, since it's already in minutes, we may not have to do the drops per minute. But I want to show you, just in following the same formula, that incorporating the micro drip IV set, since it is 60, we may not have to do that, but I want to go ahead and show you something. So we are going to have to put it into the dosage calculation here. Well, actually, we won't have to do this step because we're trying to calculate, I'm sorry, this one's kind of tricky, and I'm thinking as I'm doing it. We won't have to do this because we are trying to calculate drops per minute, and we just need it to be in minutes, and it already is. So we don't need to even think about it this way since we're trying to get it into, just milliliters. So we still need to do that top step. So the top step that I have there, getting it from micrograms into milliliters. So again, just using that one at a time, this is the number we'll use for the first dosage calculation, and this is the number we'll use for the second one. So again, we want it to be in milligrams, though, based on how the medication is supplied. Since it is 100 milligrams in 40 milliliters of normal saline there. So we need it to be in milligrams, so I'm going to go ahead and just move it 3 places to the right. To the left. Can't talk today either, it looks like. On both cases, to see what gets put into our dosage calculation in terms of milligrams. So that first one is 0.3636. I'll go ahead and use that very specific number. And then put it into the dosage calculation. This one's going to be very similar. And then put that into the dosage calculation as well. And again, it's packaged as 100 milligrams per 40 milliliters, 100 milligrams per 40 milliliters. So on both sides of the range here, so going ahead and doing that, the first one, 0.3636, divided by 100, then times 40, means that, I didn't do that right. 0.3636 divided by 100. There we go. Then times 40 gives us, this is a very strange one. I'm sorry. I got 0.145. I'll just use that number in terms of milliliters. Oh, because it's per minute. Sorry, because it is per minute. I'm leaving it in per minute for the purpose of answering the drops per minute question. Same thing on the next one, 0.7273 divided by 100, and then times 40 means that on the high end, this patient will need 0.29 milliliters every minute. Okay, so again, we need that to be in, we're trying to figure out this drops per minute calculation. So if you remember, what have I done there? So sorry, I didn't mean to put that arrow there. I was trying to erase, get out of the way. Okay, so I'm going back up here to the top to show you what we have right now. And remember our dosage formula, not a dosage formula, but our drops per minute formula says that when we're calculating drops per minute, in order to do that, we need this formula. We need to take our volume in milliliters divided by our time in minutes. We have both of those already set for us, and then we're going to multiply it by, I'll just put DF for drop factor, which is given to us in number 2 at 60 drops per minute. So I'll put these in yellow here. I'm going to go ahead and put both of these into this formula to see what that would be to get that range. So our volume for the first one, so for the low end, is 0.1, I'm going to go ahead and just round that to the hundredth place, 0.15 milliliters per, and then here's the time, per minute. It's already just in 1 minute. I didn't have to do anything to it, so it's per 1 minute, and then we're multiplying it by the drop factor of 60. So 0.15 divided by 1 is just 0.15, and then 0.15 times 60 gives us 9. So on the low end, that is 9 drops per minute. On the other end, so I'll put this one in green, we had 0.29 milliliters per minute. So that's just per 1 minute, multiplying by the drop factor of 60. So 0.29 times 60 is 17.4. 17.4 drops per minute. So there's our range for number 2. Let me circle that in blue. So on the low end, 9 drops per minute. On the high end, 17.4. That one was kind of a complicated one, but the idea for that is to kind of, again, for all of these, is to see what we have right now and then try to see where we're going. So on that one, it was a little bit different than what we had seen before. We were trying to get from, what was originally, even more complicated with it being a range, but micrograms per kilogram every minute, and we were trying to get it into drops per minute. So kind of tricky in that case because, we still did the same thing. We still had to multiply by that, the kilogram weight. We didn't have to do this because it was already in minutes, so that's why I left it. And then to get from micrograms to drops, there was kind of an intermediate step that I do need to use a dosage calculation, and that would convert it into milliliters because of how it's packaged. But then using our drops per minute formula, I can then convert it into drops and would get to this point. So that's the steps we took on that one. So that's what I mean by taking what you have to get to where you're going. Just think about what you're trying to get to. So that's why we didn't have to do this bottom step, because we were already ordered that in minutes. We just had to, again, incorporate the weight and then go from there using the dosage calculation. So I hope that helps on that one. I know that's kind of tricky on that. And then the last one, let's see. So it says the client stabilizes at 16 milliliters per hour. What is the stabilizing dose in? Oh, okay. Huh. Interesting. Okay, so I guess that's kind of the reverse in what we've been doing, in that we know that the patient has stabilized at 16 milliliters per hour. So based on that, we're kind of, okay. So this one, sorry, I should have probably thought about this and wrote it out before I recorded this. So it's kind of like doing the reverse here, that based on how this package is packaged. So 16 milliliters per hour is where that patient stabilized, and we need to know what that is in micrograms per minute. So again, to get it from hours to minutes, now we're doing the reverse, and we're actually going to divide by 60 to figure out what that would be per minute, and then we are going to use a dosage calculation, but kind of in a reverse sense here. Let's see if I can kind of figure out how to do that. Okay, so based on how that comes, if it's 16 milliliters per hour and it's packaged at 100 milligrams and 40 milliliters, let me think here. So let me show you how I'm thinking about this one, and maybe this will make sense to you. So I'm thinking about this. I'm thinking that, we don't know what that ordered number is in terms of our D over H times Q formula. We don't know what that is just yet. So I'm going to plug that in as X right now. And, based on how it's packaged, here's H, 100 milligrams per 40 milliliters. Gave us an answer of 16 milliliters per hour. As that's what, again, like I said, we're kind of going in reverse of what we've done so far. So thinking about, how we solve these typical types of problems and how we solve for X, we have to do the opposite of what's currently being done. So because 40 is being multiplied, I divide by 40. And let me see if this is going to work here. So 16 divided by 40, because we just divide on both sides. as we've done in algebra, 16 divided by 40, is 0.4. And then 100 is being, so that cancels that out, and that gives me x over 100 is equal to 0.4. And then since 100 is being divided, we will have to multiply by 100 on both sides to get x by itself. So I multiply by 100, and that will give me x is equal to 40. Is that right? Let's see, 40, that can't be right. 40 divided by 100 times 40. Oh, yeah, that is right. Sorry, I just thought that was kind of coincidental. Okay, so that means x is equal to 40. But again, that order dose is 40 milligrams. This is all over the place. So the answer is 40, and that is because, again, we were doing this. I was thinking of this as we don't know this number in our dosage calculation, which was 100 milligrams per 40 milliliters. And that gave us an answer of 16 milliliters per hour. So when we get that answer as x is equal to 40, that means that this number is 40, which again, based on the fact that that was packaged as milligrams, 40 means milligrams per hour, because it's hour, is how that was given to us. So again, we are trying to figure out what that is in terms of micrograms per minute. So let's take our two steps. So to get that into minutes, we're thinking the reverse of what we've done, and to get it into milligrams into micrograms, that's using our metrics. So 40 milligrams using the stair-step method or the decimal movement method, milli to micro is now 3 places to the right or down 1 step, so times 1,000. So 40 milligrams is the exact same thing as 40,000 micrograms. So if they're getting 40,000 micrograms every hour, well, when I take that and divide by 60, and so that's what I'm going to do here, I'm going to divide it by 60 to figure out what that would be per minute. So 40,000 divided by 60 says that this is 666 I'll just round that to 7 micrograms per minute. That is not right. That can't be right. Oh, and I meant to say that was micrograms. Sorry, Kirsten, I'm kind of thinking out loud, and I just don't feel like that can be correct. I'm trying to think about this for a second here. I'm thinking about this, and I'm on a piece of scrap paper checking my answer to see if this could possibly be correct. So I'm kind of double checking by doing kind of the reverse that we've been doing. The reverse of that one again, just because I'm used to doing it this way. If somebody did order 666.7 micrograms per minute, and we needed it to be in milliliters per hour, I just want to see if I get 16 here to see if this is correct. Well, again, we would multiply that by 60 to see what that would be in hours, and we'd have to put it in the dosage calculation to see what that would be in milliliters. Well, that times 60, so 666.7 times 60 very much is 40,000. It says 40,002, but that's just because I've rounded it. So that is 40,000, and that is micrograms right now, and it is per hour since I just did this. But then looking at that to put into a dosage calculation, that would be 40 milligrams, because again, that's the same thing when we move that 3 places to the right. So plugging that into the dosage calculation, 100 milligrams per 40 milliliters, 40 divided by 100 times 40 very much is 16. So I guess I'm thinking it's just, to me, it looks like a high number as that 666.7, but it's probably because it's not per kilogram per minute. It's simply just asking for the stabilizing dose in just milligrams per minute. So I'm sorry about that last one. That last one was kind of a tricky one for me, so you just had to listen to me kind of work my way through it. So I hope like, you know what, I hope that helps a little bit. If it doesn't, please, please, please let me know. Maybe we can sit down and talk about it. Take a look at your schedule, and maybe one day while you're on campus. I mean, I'm here now and I'm on campus all the time, so we can try to coordinate our schedules and maybe we can sit down and go over it if that would be easier. Just let me know. All right, thanks, Kirsten.